Great day. Oh. Okay, what is happening here?
I know you missed this.
Wait, what just happened?
What is going on? Oh no.
Something is different about today. Wait, what?
Wait. Now I feel like fighting crime. Joker!
Something is definitely not right with this.
Now, that one I'm not too sure of. Ladies and gentlemen, I apologize for beginning of today's video. I had this thing planned. Oh, I'm feeling something. Now, this is just getting ridiculous, ladies and gentlemen. I want to teach my science lesson, but I keep changing. Great day, students. It's Mr. Sargent here, and I am sure that it's Mr. Sargent this time. Today's video, like I said before, is all about change and changes. Now, I had to change today's lesson because of different circumstances. We were going to do the treasure hunt today and learn how to use a map, but in preparation for tomorrow's lab, I wanted us to make sure that we knew about changes and why things change. So, today's video is going to be dedicated to both physical and chemical changes. First, let's talk about what change is. Change is something that's different. It changes how it looks, it changes something how it sounds, how it tastes, how it is. Change happens. But if we're talking about physical and chemical changes, these are totally different changes that we really need to take a look at. Now, the first thing I want to talk about is physical change. But first, I think what we need is a vocabulary video to sort of warm us up to both physical and chemical changes. So, ladies and gentlemen, sit back and let's listen to the vocabulary video.
Yeah. We got two types of changes. We got physical and we got chemical. We about to break it down. Let's go.
Yo, what's a physical change? Listen, a substance may change in appearance, but not in composition. That means the chemical bonds stay the same. That means the molecules don't rearrange. Let's say you have graham crackers and you're ready to snack, but they get smashed up in your backpack. Even though they got crushed to crumbs, they're still made of the same stuff that make you go, yum. Or what about a day that's so hot and melts your popsicle? Now what have you got? You had a solid, now it's a liquid. A change in the state of matter while it goes drip drip. Or say you're blowing up a balloon that's only changing its shape and volume. Or if you tore up a piece of paper, its mass and size have changed and you need a stapler. Or if you crumpled it, it would change the texture. All those are physical changes. And next up, when I put sugar in my cappuccino, the sugar starts dissolving. Yeah, and we know when something dissolves, it makes a mixture, which is a physical change. Get the picture? And when a mixture gets created, its parts can be physically separated. Let's go. Physical change changes how something looks, but the chemical bonds stay put. But wait, in a chemical change, the molecules link up in new ways. Physical change changes how something looks, but the chemical bonds stay put. But wait, in a chemical change, the molecules link up in new ways. Now let's talk about a chemical change. That's when molecules link up in new ways. See, the bond between molecules breaks. For example, what if we're baking a cake? As the batter cooks, those changes a chemical. The same goes for cooking raw meat or vegetables. You see rust on your bite after it rains. That's not just a shame, that's a chemical change. So how do you know when one is happening? Check the evidence, let's get some practicing. Do you see bubbles? That could be a sign, but not from evaporation. These are another kind. Bubbles can indicate a substance is forming. If there aren't bubbles, check a few more things. A change in the pH level, taste, or smell could mean chemical changes as well. When you burn a match, there's a smell that is strange. That's evidence of a chemical change. Wait, you could also check for a precipitate. Like if you leave milk out overnight by mistake. A precipitate forms at the top, check the chunks. That's a chemical change, it stinks like a skunk. If you want more signs, here's another. You can check for a change in the color. Yes, sir. Like when your bike gets rusty. But you gotta be careful, trust me, because the color change could also be caused by a physical change. Yeah, that's all. Like you can paint your bike red hot. The color has changed, the composition has not. And physical changes are easier to reverse. Reversing chemical changes, that takes more work. Physical change changes how something looks, but the chemical bonds stay put. But wait, in a chemical change, the molecules link up in new ways. Physical change changes how something looks, but the chemical bonds stay put. But wait, in a chemical change, the molecules link up in new ways.
I've said it before, I'll say it again. Thank you, Flocabulary, for an incredible video, a lot of information, a lot of facts, and a lot of key terms. But let's break it down a little bit. To talk about physical change, I need a different environment. All right, here we go. Now, if you look behind me, ladies and gentlemen, you see a nice forest. And the forest once was green, but then it turned into fall, just like the season we're going through now, because seasons change, don't they? Now, what do you think the trees, or how do you think the trees look like now? Well, if you look at them, they changed their color, didn't they? But are they still leaves? Yes. Are they still trees? Yes. The only thing that changed is how it looks. Well, if you don't understand that part, let's take a look at this. Let's take a look at just an ordinary piece of paper. You know, right? We find these papers everywhere. If I fold it in half, it looks different, but is it still the piece of paper? Well, the answer is yes. We just changed how it looks. What if I rip it? Well, yes, it's still the piece of paper. It has the same weight. It has the same mass. The only thing that's changed is how it looks. How about if I crumble it up? Is it the same paper? Well, yes. It just looks different. What if we put a nice picture on it and colored it? Well, yes, it's still the paper, isn't it? Because when we're talking about physical changes, they're talking about changes that can be reversed. We can always go back to this being an ordinary piece of paper. See, if we're talking about physical changes, ladies and gentlemen, all we're doing is we're changing how it looks. Now, can it always go back? Yes. I want you to think about the water cycle. I love the water cycle because it is the greatest example of physical change. Water changes from a liquid, and then it gets heated up and evaporates into condensation, but it's still water, isn't it? And even when water freezes, guess what? It's still water. It may look different, but it's still water. That, ladies and gentlemen, is a physical change. Now, on the other hand, we have chemical changes. Ladies and gentlemen, these ones are a little bit more complicated. Once something is changed chemically, it cannot be changed back again. We change the entire structure. We change what it is. It's no longer what it started off as. Take, for instance, this piece of paper. Now, if I put this piece of paper over a campfire, what would happen to the paper? Well, the paper would burn, wouldn't it? And it would turn to something else. It would turn to ash. Can we ever turn it back to paper again? No, we can't. Once it's burned and once it's chemically changed, it is changed forever. That is the definition of a chemical change. Can you think of another chemical change? Well, how many of you have bikes out there? You. Okay, good. You guys have bikes. And I know your parents tell you to leave, after you're done using them, to put them in the garage or bring them inside because we don't want to leave our bikes outside. Our bikes are made of metals like aluminum, steel, iron. And what happens is if you leave them outside and it rains, the water mixes in with the metal. Now, does this happen instantaneously? No, it takes a long time to do. But the molecules in the water mix with the molecules in the metal, and it creates a chemical change. And did you ever notice that maybe the next day or the week after, the color of the bike changes? Maybe one was nice, shiny metal is now an orangey rust color. Because what happened was the metal turned to rust. Can that rust ever be turned back to the metal? No. Once it is changed, ladies and gentlemen, it is changed for good. That is chemical change. So, quick review time. If we're talking about physical change, it's a change that doesn't change what the object is. Sort of like this balloon. I can add air to it. There we go. I can add air to it, but is it still a balloon? Yes. It has the same molecular structure as a balloon. This is a physical change. But if we put that balloon over, say, a campfire, or we mixed it in with some chemicals that broke down the rubber and plastic, could we ever turn it back into a balloon? No. So physical change can change back. Chemical change cannot. So your activity, which is right boop, here, you will see there's a list of 12 different scenarios, everything from melting an ice cube to mixing baking soda and vinegar. Ladies and gentlemen, what I would like you to do is go through this list and decide, is this a physical change or is it a chemical change? Ladies and gentlemen, I cannot wait to see your incredible work. And that's it for today's video. Ladies and gentlemen, I hope you enjoyed it. Hopefully you understand physical and chemical changes a little bit better, because in tomorrow's video and in tomorrow's class, ladies and gentlemen, we are going to be doing a number of experiments that show both chemical and physical change. So ladies and gentlemen, have a great night, and I will see all of you tomorrow.